It is my pleasure to introduce the man who needs no introduction in our community, Byron Cook, these days at Amazon Web Services. Please take it away.
All right, thank you very much. A lot of folks kind of know what's going on Amazon, so what I thought I would do is give you kind of a very brief State of the Union. This will probably be a repeat. Some of you have seen that, but I wanted to kind of baseline us, and then I wanted to spend the majority of my time up on stage talking about opportunities and challenges. To keep things spicy, I want to make some predictions, and then I'm hoping to leave actually lots of time to discussion. I think that this might be maybe 15, 20 minutes, and I think I have 30 minutes. So I'm hoping you'll help make this a great experience by asking lots of hard questions. Okay, so this is the State of the Union, kind of where things are in formal on Amazon. So from a customer's perspective, there's lots of products like Managed Config Rules, S3 Block Public Access, IAM Access Analyzer. These are all available to customers. This is actually, these three are actually based on an internal service which we call Zelkova, and Zelkova is the formalization of the semantics of AWS's policy language into SMT, and then we discharge questions about those using SMT. And so there's a paper that describes that. And then we also have another suite of tools that reason about virtual networks. So there's a thing called VPC Reachability Analyzer, and there's features in a service called Inspector. And that's also powered by an internal tool. And so what we do is we formalize the semantics of EC2 networking into logic and discharge those with solvers. And then there's a paper on that. And then we also reason about our open source, bunch of open source code. So for example, the encryption SDK, this is something that customers use to encrypt stuff before sending things into the cloud. There's been a recent really interesting work on, there's something called SampCert. It's the samplers used in differential privacy with proofs done in Lean Theorem Prover. And then we're doing a lot of work on the proofs of the crypto foundations. There's actually some people in the room doing that work. And then there's just lots of other stuff going on. I thought I'd mention a couple that we're doing we have sort of cloud scale solvers internally within Amazon. And I'll say a few words about how we're actually distributing solving. And then the kind of fun fact is that these are actually, they're getting used to make Amazon products better and to help customers. But there's also, for giggles, we're off proving things like the happy endings problem and stuff like that. So anyways, so that's the customer's view. Let me just say a little bit about inside. So within AWS, basically these days, it's safe to say that every area of AWS is in some way touched by automated reasoning. So directly, in these cases, I'll talk about indirectly in a moment. So one really nice data point that we've got now is reasoning about authorization. So there's a very nice talk that came out this year, which I highly recommend watching, which is about this work. So basically, AWS gets called approximately 2 billion times per second. So so when you call AWS, you make an API call, and you have a principal, and an action, and a resource, and you're asking AWS on your behalf to take action on the resource as the principal, and you've already authenticated, and then the action. And so there's a set of policies with regards to the resource and a set of policies with regards to the principal. They all get pulled together. There's a policy evaluation engine, and that happens 2 billion times per second. And so what happened is that over a 5-year period, we rewrote that code in Daphne and proved it correct, and I'll tell you what correct means in a moment. And lo and behold, it's actually 50% faster. So that was a little bit of a surprise to us. So part of that was because we were able to do quite aggressive programming because we had the prover on our side. So correctness is defined by that product called IAM Access Analyzer, which is basically Zelkova under the hood. So the property is something like, for all possible requests, do denies in the policy always take precedence over allows in the policy. So that's basically what we proved. And we've got this kind of work going on in a lot of other parts of AWS. So in the storage subsystems and in the virtualization subsystems and the VPC. Hold up your hand if you're in the room and you work in AWS storage. So there's someone to talk to about storage. Hold up your hand if you work on EC2 virtualization. So those are a couple folks that you'd want to talk to if you have questions about that. And then we don't have anyone in the room working on this part, so I'll just say that there's some work going on internally to actually connect up the semantics of the EC2 networking to the actual implementation of the EC2 networking in AWS. Okay, so then everyone, all AWS services use networking, they use storage, they use virtualization, and they use cryptography. So by that rationale, I can say, all of AWS is, there are, it's the automated reasoning or formal, whatever you want to call it, touches all possible products. And it's also worth mentioning that Amazon.com is built on top of AWS. So when you're ordering a book, in some sense, you're benefiting from formal. Okay, and then a couple of interesting things that are going on sort of cross Amazon. So we're beginning to look at using data flow analysis, sort of reasoning about the entire AWS system. Not saying that's happening at any level of scale yet, but and that is across mixtures of infrastructure as code and code. So imagine here are all the data centers. If you're in the UK and you're trying to send data to all the other data centers, there you go. And then you could begin asking questions like, hey, I want to keep all of my metadata within the European Union. And that's the kind of thing you could do with that kind of work. Okay, so that's a snapshot. So let's now get to the more reflective, depressing part, if you will. And so I recently went through kind of an exercise where I was trying to write down a lot of the problems we have. Part of that's because, and I'll say this in my predictions thing, because neurosymbolic AI, suddenly formal methods and automated reasoning is super hot, right? And so it's like a very exciting time to be in the space. And so there's sort of a level of resourcing that I'm seeing now that we just frankly didn't have before within Amazon. And so it's sort of like now's the time to write down all the problems, to use the gravitational pull of neurosymbolic AI to go tackle a bunch of these challenges too. So I've kind of written a bunch of them down. I'm going to share 5 of them with you. Okay, so depressing fact number 1. Let's say you've proved a program and you've deployed it in your data center and you've told everybody it's been proved. And then it's running in the system. Like, well, what if the microprocessor has a bug, or what if the language runtime has a bug, or what if the environment assumptions, like you formalize some third-party API and you're proving against that environment assumption, but it turns out not to be true, or what if you almost prove the correctness of it, but there's like one lemma left and you didn't quite get it done, but you deploy. Does it really mean you know nothing? And that's kind of like the story we have right now, right? It's like, oh well. If the compiler hits a problem, or if the microprocessor hits a problem. And so this is sort of a big area that, like, people who love formal methods, they're really excited about them, but then people who are sort of like act like they don't care about formal methods, but they're kind of trying to understand the benefit of formal methods, this is where they begin to get really disoriented, because they're like, oh, so it actually doesn't mean what, like, and they can't really think about, like, it's like, well, yeah, it's so like, clearly it's something you should do, but like it's pretty expensive too, and then you're not really getting the benefits you're claiming. And so a couple of the talks we've heard earlier today were wildly overclaiming the results, because we, as formal methods experts, we all understand, oh, well, they don't actually handle weak memory in LCL4, right? And oh, actually, when you want to use Morella, or what's it called? Help me. Jerry, you actually have to go and do a bunch of work to recompile your program, right? But we understand that, but then the people kind of outside our community begin to sort of copy and paste those messages, and all the sort of subtlety gets lost. And this happens to us too, right? There's a game of telephone, like we proved the identity subsystem, right? Under conditions around the Java runtime and the microprocessors it runs on, but all of that subtlety, all those like pieces to the left of the implication kind of get lost as the executives begin to talk about it with customers. And so that turns out to be a real drag. And so here's, Amazon, we build our own chips. So this is a picture of the Graviton chip. And so the thinking that was kind of in our head is like, imagine a chip takes a step from one step to another step, right? Couldn't we do some runtime? We make a lot of chips. Could we just add another chip and kind of check some of those assumptions at runtime, right? And maybe the assumptions that we couldn't quite get proof to go through, the environment assumptions about calls to the outside or the correctness of the microprocessor, like maybe if we had the semantics of the language and we encoded that into logic, couldn't we check that the microprocessor as it's running is actually respecting that semantics with us? So that's kind of something that's kind of in our head. We do a little bit of this today. So currently we proved the correctness of S3's strong consistency at the protocol layer, but then for the code itself, we actually do runtime verification, and then we just page someone on the team if there's a bug, right? And so the Gustavo can tell you all about that. Okay, so second is kind of depressing a bit. So it turns out that we spend a lot of time working on specifications. This came up in one of the talks earlier today. So let's go back to 2015. I'm using these little toys as representatives of Amazon employees, and it's 2015, and so I've got an identity expert and a formal methods expert, right? And we're trying to build Zelkova. So the identity expert is like, oh, here's what I think this formalization of identity, the policy language should be. And then we're like, great, and we'll formalize that into SMT, right? And then we give the identity expert some examples. And then she's like, no, that's not quite right, right? And so then she does it again. And we basically go round and around and around. And this is an extremely painful process, right? And every time that you make this around, the non-expert is more and more likely to leave the project. And so, I mean, it ultimately paid dividends because this work we did back in 2015, 10 years later, is the thing that we now approve of the code. But wow, it took a super painful to develop that. That is also very durable work because still to this day, we're actually adding to that specification. And what's really fascinating is in the networking subsystem and the identity subsystem of AWS, the people who understand those systems now are formal people. So if you're in the solutions architect in the field working with the customer and you have a particular question about how EC2 networking works, the person they're going to point to actually owns the formalization. So it's very durable, but very painful. And so what we'd love to do in 2025 is to use generative AI, right? So could we get the generative AI to help us write the formalization and then use the formal methods tools to sort of walk through those scenarios and then help the non-formal methods expert kind of understand those in a way that they can understand it and go around and around. And so that's our hope. And then the other observation I have, what's remarkable about Rust is somehow Rust tricked the world into doing memory safety proofs without them even knowing that's what they were doing. And so I spent a lot of time trying to get the EC2 virtualization team to use tools like checkC to prove the correctness, to prove memory safety of the code they were writing in C. And they were like, no, it's too hard. And then one day I wake up and they're all just writing in Rust. So that's curious. So our belief is that one of the big things that they got right were the error messages. And as someone who's myself used Rust, I really agree. The error messages are pretty remarkable, and they're remarkable for humans, but also for AI tools that we might be using in the future, trying to help write those things. Okay, let's be honest. Proof is undecidable, and it's going to remain undecidable for a very long time, right? And so it's what sort of distinguishes proof from non-proof is that undecidable or intractability. And so the user experience is quite interesting. You need to be even closer to your customer than you would normally when you're doing proof, because you're always going to need a person who's writing the program to help nudge you along. And sort of the experience, I heard sort of some comments around, oh, we don't really see model checking used very much. The reason is because push and button isn't really ever going to work, right? Like it's because you always do need someone to kind of guide you along. But it's not also a very good answer to say, oh, you have to go learn, lean theorem prover to make things go along. So there's got to be some middle ground there where we help, where we encourage the developer of the code in a way that's intuitive to them to nudge things along a little bit. So our challenge is to get here quickly, right? So this is the Daphne IDE integration. We need to get to verification succeeded, but without a formal expert at the top of the stack, using Daphne, which uses Boogie, which uses S3, right? We want in the future the identity person who doesn't know formal at all to do that. We're not there yet at all, very far from there. But the hope is that Rust style error messages and bots, and then the Rust style error messages helping bots can help that person along. Next point. So, and right on time, actually. I don't know if this has all occurred to you, but to me, this came as this like huge aha moment a couple weeks ago. Durability is to storage as maintainability is to proof, right? If you have a bunch of data and it's really important for you not to lose it, then you're going to store it on a system that has durability, that's focused on durability. That's what's made S3 so popular. If you're going to prove a program that's of any importance whatsoever, that program is going to evolve. So thus, it doesn't help you at all to, well, it helps you some, but it doesn't help you very much. It degrades the utility of doing the work if you prove the program and then 3 days later the program's evolved and you don't have the proof anymore. So thus, in industry, kind of what we've seen is that the maintainability or the CI/CD integration of these tools is super, super important. It's not really something that really shows up in the academic work, but in the industry, it's like the third question that comes up when you start talking to leaders in AWS. It's like, okay, great, so you proved it, so it's like this code is what's running today? Well, no, we proved it, but it's changed. Well, like, why did I pay for it? And so there's some work in the provers, the DARPA provers program. This has kind of been a focus of theirs, and it's super important to us. So the problem is, right? You have a proof, you have a program, you modify the program. Okay, now what do you do, right? And this, that's bad. So usually proofs have sort of a mixture of manual and automated. It's bad if when you're trying to update it requires lots of manual work. It's good if you can, like, if you did a proof and it was like super manual and difficult. I can imagine, I wasn't involved in SCL4, but I could just imagine it was horrible, right? But now you're trying to change the kernel. If you can automate the rediscovery of the proof, then that's magic, right? That's total gold. So that's kind of where we would like to be. And so what we are looking at as one of many approaches is using generative AI, especially if this vision is true that bots are going to be modifying the programs too, right? So why not just ask the bot to find the proof while it's writing the program at the same time? It's kind of where our head is at. Okay. What do I want to say here? So one of the interesting trends I'm seeing in Amazon, which caught me a little by surprise, since I'm really a big fan of SMT solvers, is this sort of, a lot of people are moving to lean and away from the automation of SMT. And it's actually because of some of these issues about durability of proof, right? So we have folks that are really good at running these provers, but then they get super frustrated if Daphne kind of doesn't let them, imagine the Daphne proof isn't going through. Like, what do? Right? It's something that's like, oh, well, the heuristics for resolving quantifiers and in the SMT solver are having a bad day. Like, there's kind of no recourse. They just sit there and be frustrated. Whereas if they go to lean, it's like, well, at least they can kind of dig in and get the proof to nudge the proof through. And yes, that isn't a great exercise for people who aren't experts, but for experts, they can at least get the proof to go through. And then the hope and belief is in the future when we need to modify the proof because we've written the proof down, maybe that's a little better. And what's really interesting these days is that lean is a huge source of data for large language models being trained. Right? If you look at a lot of large language models that are commercially available and you kind of talk to the people about how they trained them, like a lot of them are training over lean proofs. And one could synthesize additional lean proofs. So basically, kind of out of the box, some of the large language models kind of already understand lean. And so that's our hope that these proofs that have been done in the theorem, and what I'm saying is true for Isabel too. These proofs that are done are material over which to train, and so could we get a bot that helps us maintain these proofs? The other swing, and this I'm very excited about this work because I'm of course a huge fan of SMT solvers, is the quest for distributed search, and so my belief is that by distributing SMT proof search, we can do a lot more and storing and persisting lemmas, that we can do a lot of good for handling quantifiers and strings, and by the way, quantifiers and strings are like a huge pain point for us with SMT today. So we basically, underneath the hood, have swapped in a different solver, and this solver is distributed. So it uses hundreds or thousands of machines they all run on that same question, but in kind of different parts of the space, and then they share conflict clauses across a network. So hold up your hand if you know Malib Mono, by the way. That's really interesting. This work is totally incredible. So welcome to the future, people. So I'm going to show you a graph. How you read this graph is the solver on the top could solve 295 problems in 600 seconds each, and the next one down 150 problems in 600 seconds each. So the top one is clearly better than the bottom one. This is a graph of all of the winners of the international SAT competition from 2002 to 2020. This graph's a little bit, I've given this the talk based on this graph a couple times, so it's a little bit old. Need to update it. But the only solver that, this is slightly unfair, the top, that black solver is actually a distributed solver. So all the rest of them are sequential, and the top one is a distributed solver. And so basically what you're seeing is, this is 20 years of SAT. Oh, by the way, I should say, all the winners of the international SAT competition compared on the same hardware on the same benchmarks. So this is an apples to apples comparison of the different solvers for 20 years. And the solver on the top is a distributed solver that's sharing conflict clauses across the network. So the great news is that there's like game-changing performance available to you. The bad news is it's a distributed system, so you're going to need a team to run it, right? So if you have a sequential solver, you can just download, compile, go. With a distributed solver, you need a team and pagers and all that kind of stuff. So that's kind of where our head is at AWS. And I think FMCAD's really soon. Maybe it's just happened. Maybe it's going to happen. But we have a paper, for example, in the space that we're pretty excited about. And then the other point is, when you're proving a program, probably the program that you're proving, you proved 3 weeks ago, and it wasn't all that different, right? Or if you're reasoning about a policy, or if you're reasoning about a virtual network, probably the network hasn't changed that much. So probably you could store and persist a lot of the reasoning you've done before and just kind of re-stitch the proof back up together. So a kind of an area where our head is at is that how do you do that? We don't have great answers. Okay, so let me give some predictions. Remember, this is to be spicy, right? So coding bots are going to force the industry to adopt formal specification. Why do I say that? Always until today, we've used, what's the word? Techno-social mechanisms, right? We've used HR systems to keep the bar of quality at the level it's at in companies, right? If you don't figure out how to write good code and kind of figure out what needs to be done, you're fired. That's been our answer, just to correctness, right? But going forward, you're gonna have just kind of bots like generating code. And so how are you can't fire the bots really, like, and they're so cheap, you're gonna wanna run them. So what you're gonna suddenly want to do is to write down the things that you didn't bother to write down before. The reason you didn't write down before is because you had humans doing the work, and you're like, well, they're actually pretty smart. So they'll go talk to they'll kind of figure out the spec on themselves, for themselves. They'll go talk to the right people, we'll work it out, and then they didn't quite formalize it, but they did pretty well, and then we don't see that many bugs, and it's kind of not worth to then go like learn LTL or CTL or some formalism. But I think now the economics of that whole thing sort of shifts, because executives are just looking at like, oh, I could just have fleets of bots writing code. One small problem, what's correctness? And so I think that this is going to flip that thing around. So the good news is I think specification is going to be pretty hot. So I already said that, great. Formal reasoning over code will be driven by performance, not correctness. And you see this with Rust. This is not true at AWS. Security is at problem zero. But what I see when I talk to customers a lot is that they're like, and this is the talk about hardware. It's like you go and people are like, oh, it's 3% slower. Like, oh my God, are you serious? Like, it's so important to get this correctness up. But then if you go to them and say it's 20% faster, they will reprioritize everything, right? And so for better or for worse, that's the truth. And so I actually just on the 2 days ago, and I've just posted on my LinkedIn this morning, we have an article that shows that proved programs are typically faster and usually faster to deploy. And we provide a bunch of data to that effect. And so that has been very exciting. So often when we're doing proof, So at AWS, we have a weekly meeting where all of the general managers and most of the principal engineers and anyone in AWS can come. And it's a 2-hour meeting, and we go through the sort of outages, and then we spin the dial, choose a team, and then we kind of, as an organization, all look at that team's service and kind of look at their metrics and talk through a bunch of stuff. And so every week there's kind of wins, right? And a lot of the wins are about like, 4%, performance increase on the parsing for network what's-its, right? And so what we've kind of learned is that it's really hard to talk about security. So imagine I found a really horrible security bug. I'm not going to go in front of the entire AWS so that they can learn about this horrible security bug so they can leak it to the New York Times, right? But we can talk about performance benefits, right? So we can say, oh, it's 10% faster, it's 20% faster, and then that grows virally and the whole company gets really excited about it. So what we're seeing, even within AWS, is that people get super excited about performance wins because they can talk about them, they understand them, and it's something that they've been sort of trained to go after. Whereas security is kind of hard to understand. Anyways. I do believe that formal reasoning will take over regulatory compliance. I see a very large number of people doing regulatory compliance who don't know what a for loop is. It's very frustrating, but it's a kind of a build it and they'll come situation. I think I believe, I'm very confident in this, that in time, once these tools become, because right now what happens is you talk to somebody in the compliance space, right, an auditor, and you're like, you should be doing proof of memory safety, and they're like, great, sounds awesome. What's the tools I should use? I'm like, ooh, now I think now I'm backpedaling, right? I'm like, let's talk in a year, right? Like even today, after all the tools we've developed, you point them to tools, suddenly it's like they're in this sort of or they'll go off on their own and they'll come back with these horror stories about they went and learned some obscure tool and they talked to some academic and the academic totally vectored them off into some horrible space. So it's very frustrating. But when the tools are ready to use, I believe that the industry will flip, because I believe that it's a huge issue of latency, right? I know of customers, and I won't say what their IT provider is, but they use AWS, but they use other folks too. But for certain IT providers that they're using, it'll take up to 18 months, if not longer, to begin using a new feature from that IT provider because of regulatory issues. So they'll have to, and this is huge pain point. There's very large amounts of money left on the table because they can't use they want to use the feature for good reason. Probably there's big benefits to them. Probably security, frankly, right? But they can't use it because of compliance. And the reason they can't use it the problem there is that the compliance community literally doesn't know how a for loop works. So you're trying to do all this education at the same time you're trying to help make the right thing happen. But then the tools don't really work, so they're not really going to be able to. So if we can get the tools to some level of maturity, I believe suddenly, it's sort of I remember being as a kid, it was inconceivable there wouldn't be smoking in pubs. Inconceivable. And then suddenly one day you wake up and you can't smoke in pubs, right? So it's so I think we'll kind of see that somewhere, or all of a sudden everyone wears seatbelts, right? So I think that at some juncture when the conditions are right, this is going to happen. And I'm very excited by the back to the building blocks work. So, but the challenge is, for us, is to not allow people to use formal as a checkbox, right? Oh, I proved it, right? I proved X is less than Y in one line of the program, thus it's proved. Sorry, I was wrong about my assertion about time. Neurosymbolic this is a super hot area. Look at the Gartner hype curve. The formal methods is hot. Super hot right now, and we're not used to it. So there's a bunch of good things and a bunch of bad things. So tell your departments to start hiring now, informal. Right now, what happens is someone joins Amazon, they're a formal methods person, the department replaces them with an ML person, and so that's kind of a problem. I'll skip over that. Okay. So thanks very much. So we're hiring. Scientists, developers, interns. You need a program. You can't come and just be a theoretician. And right now it's a lot of work going on in the U.S. So I do believe we'll be growing more in Europe in the future. But if you talk to me, the first thing I would be like, hey, do you want to move to the U.S.? So thank you very much.